So without further ado, I'll pass it over to Jason.
Thanks, Matthew. All right, so the impetus for the RPCCR tool, which is riparian planting, riparian prioritization for climate change resilience tool. That's a tough one for me to remember. Is basically in this, impending climate change. If temperatures get warmer, streams are going to get warmer. So one way to combat that is basically to fill in gaps in the canopy in the riparian zone to try to shade the stream to prevent solar gain from heating up the water. But we wanted to make a tool that was very flexible in this design so that the end user could specify whatever parameters they wanted to find these locations and also find them in the area that they wanted. Since the joint venture range is very broad, we don't want to average over, say, Maine down to South Carolina because we're going to be skewed in the numbers, right? So with those things in mind, we try to make it as flexible as possible, and I think we did a pretty good job. Not to pat myself on the back or Matthew for getting this going, but so if you click on the RPCCR menu button up there, you're brought to a familiar area. We got a map showing the whole region. And if we scroll down, this is where your input is going to be valued. So right away you can select what layer that you want to constrain the analysis by with a feature within that layer. As we move forward, we will make it so that as you upload layers, they will automatically be added to this drop-down box. At this point in time, there was just a few layers already uploaded into it, but so we'll start with just a Huck 12 or the sub-watershed scale, which we've been talking about quite a bit this morning. So when we choose that layer, we can see that it's starting to be added to the map. It's a fairly large layer, so it's going to have a little lag.
And probably everybody else is doing it at the same time. So.
And we're as far out extent-wise as we, we don't need to be this far. We can
Right.
focus in. We can do whatever we want, right? Minutes, seconds, whatever. But in this case, we'll just do plain old Shepherdstown. So that layer is still highlighted. If I scroll up, if you click over the layers up here, you can see that our Huck 12 layer is indeed highlighted. You can turn it off if you want, turn it back on. So now, whenever you click on the map, one click, nothing special, just one click on the right-hand side, it will select the feature that you are currently over and zoom out to the extent of that feature. So just what Matthew showed you earlier. So now we have selected the Huck 12 surrounding Shepherdstown. And again, if you click on it again, it brings up the information for that layer. So most of us don't know the Huck identifiers off the top of our head, so let's take it. But it does at least give you a name for the Huck 12, which is nice. So now we need to make some decisions, right? We need to decide what we want to do. So say we have some money, which is great, right? Somebody gave us some money to do something. So now we want to plant some trees in this Huck 12 to try to maximize our shade on these streams. So what we really need to know is where do we plant the trees? So we need to put in some specifications here. So what is the maximum canopy cover value that we want to be able to select? So if it's greater than this number, we don't care about it. It's already got trees. So 70 seems to be a decent number. Mark, you have some biological reason for that? Wasn't that the average for the from the CART model?
That was the median. Yeah.
Median, yeah. So in the CART model, sub-watersheds with that amount of canopy tended to be classified as brook trout habitat. But you're free to change that to whatever you want. Then you come down to the solar gain percentile. So this is the layer that basically says for each cell in that raster, so each cell is 30 meters by 30 meters, it tells you how much energy from the sun is being input into that 900 square meter area. This was a layer created at JMU using an algorithm from a paper. I can give you the PDF reference if anybody wants to know. But basically, it's telling you how much energy is hitting that one pixel. But it's given as, an absolute value. So what we don't know off the top of my head, I don't know how much energy hits that pixel. So we changed it into a percentile, and we wanted this to be relative to the other cells that are in that feature, right? So we're restricting it by that HUC12. We want to know how many of those pixels are greater, in this case, than 70% of all the pixels in the riparian zone. This is just for the riparian zone, so 100-meter buffer on either side of the stream. How many of them, I want to put in the restriction that they have to be greater than 70% to be considered as an impact cell where I want to plant a tree. And we can change this number to as one. If you only have limited money, you might want to make this 90%, and seeing what the output gives you, then you can play around with the numbers. But so say we only want the top 10 hottest spots in that subwatershed that have no trees, or trees that are less than 70%. Now the other two layers, elevation and impervious surface, are optional. The first two layers are not optional. You need those values. That's the minimum information that we need to query those rasters and give you your output. Now you can choose, well, I know brook trout don't live down low, so I'm going to say I want an elevation higher, probably not 600 around here. We wouldn't have anything, right? What's the elevation in Shepherdstown? Anybody? Who's Maryland or West Virginia? What are we at?
About 800.
800? Oh, so maybe 600 would have been all right. We'll knock it down to 300. We'll be conservative. So we'll say, I want to use the elevation, and I want it to be only elevations that are higher than 300 meters, because I feel that would be the best chance of where brook trout would be. And also, I don't want cells that are parking lots, right? I want to plant a tree in the dirt. So I'm going to say the impervious surface has to be less than 10%. So it can't be a lot of pavement or anything like that. Usually, hopefully, you're not finding a lot of that in the riparian zone, but just to be safe, we'll put it in anyway. So once we have our parameters set, we're ready to make our request. So this is where the magic happens, right, Matthew? We hit our button, and what we're doing is we have a little status update over here telling us that it's going out into the PostGIS database. It's querying it based on the parameters we just put in, based on the spatial, and it's restricting it by the spatial feature that we selected, and it's calculating where those cells are that fit our criteria. And I will fill space until that gets done working. So, hopefully it's not too long. I'm not good at filling space, I guess. 400 feet. We might be a little.
What's the ID of that?
38247. So we're not going to get any, potentially.
Hey, Jason, could you go over what metrics are derived, how you get that solar gain percent, or all the different metrics that go into that? Solar gain, it hits that 30-meter pixel.
Possibly. I'm trying to remember it off the top of my head. I haven't looked at that paper in a while. So basically, it calculates the sun as it passes over, given your latitude, your elevation, your aspect. Did it include canopy cover? Do you remember?
Yeah, it can do with that. So, I mean, the key thing is that all 30-meter pixels are created equal, and it's amazing the variation within a stream in terms of solar gain. Sometimes a 10-fold increase in solar energy, name that, just from an aspect or an elevation, DEM, mountain, shade, and things like that. But the tool basically simulates the sun going over that 30-meter pixel for an entire year, calculates the energy hitting that. So areas with high energy and no trees would be priority areas versus something that has no trees but it's completely shaded by a mountain or something wouldn't give you any gain.
So we got our results back and we found no positive sites because they should be black, but that's a good thing, right? If we put in 300 meters and we're not anywhere near that. So let's put down, we'll knock it down to 30 meters. We'll be really, really wide open with what we take, and we'll just rerun that request again. But as you can see, the first request was completed. It gives you the opportunity to, if it's not already displayed, you can bring it back up. And the nice part is that you can actually save this as a GeoTIFF and export it to your, if you want to take this out into your own desktop GIS, or load it on a field, some type of field computer, and bring it out. You can do that as well. So you're not restricted to just having it here. Are there any questions while we're waiting for this to load? All right.
How did you get it to do just the hut for Shepherdstown again? I missed that something like that.
So you select what layer you want.
Yeah.
You go onto the map where you want to be.
Shepherdstown, yeah.
Yep. And then you just click on the map.
Can you do more than one hawk at a time?
You can, but I'm not sure if the select is multi-select on yet.
No.
We can turn multi-select on.
However, you can run them sequentially. You can run one, and you can turn them all on at the same time.
But that
If
would
you-
potentially give a different distribution.
That's true, right?
Yeah.
So yeah, Jason had identified that as a feature that should be added.
So the nice part is that while this one's finishing up, this layer is already, or this the first run has already been added to the layers file. So if we go to the layers, and we can leave that. The nice part, what Matthew did is he basically made that an asynchronous process, so you don't have to stay on that page for that to complete. It'll do it automatically. And this is the one that we just ran, the one that returned nothing because of our altitude. But we can actually now go to the maps, or actually we'll make a map. Go back to the layer. Whoops, I want to create a new map. We'll get there. Create a new map. And we should be able to add layers.
Yeah.
No?
Yeah. Add layer. Oh, you know what? It's because you're not signed in.
Oh, I got signed in.
I thought you could add layers if you weren't signed in, but I guess not.
Jason, while you're signing in, I think also there's an area on the Geonode for documents, and when we were preparing the issue for presentation.
No, but you know what? You can just log in as me.
There are a lot of questions about how did you get this, or
Or I'll log in as the administrator.
You will have the answers to those, the papers that are associated with the tool available to you inside and from the Geonode.
All right, let's go through this again.
Ports associated with that area. So as you start building not only your data sets as a planning tool, but when you're feeding back your reports or site visits or restoration photos or video clips or whatever you want to do, because you have this multi-level content management system, you can have all of that associated with that one site, so that when folks come to your site and go to the conservation design and click on that project area, they can see that, they can see what's associated with it, and all of your associated work. And I think Callie's going to be talking about some of the other reporting, so the issues of who all was involved, volunteer hours or in-kind contributions, et cetera. So it'll be fairly rich content management that'll be geospatially referenced.
So just for the record, I just got this error code that says the server returned an error 504 gateway timeout. What's that mean?
That's a timeout. That's because I've been watching these logs go by. There's like a million of them with all the people using it.
So that's a common thing.
It is with this many people using it. Yeah.
Okay.
When you have this many people hitting it at the same
Yeah.
time. Hit it different.
Yeah.
Even in one room, one environment.
This was intentional, though. This is load testing.
24 more people in Kenya who are on at the same time.
So,
Is that working?
no, it seems to be hung up, potentially.
Yeah, Jason, I've been hung up here for a while. It seems like it's.
The lines, yeah, that comes, that's the geotiff file.
Okay.
So that, basically it comes out, the cells are either coded as 100, meaning they did not meet the criteria, or 101, which are black, which means they did meet the criteria. That was run earlier. So you can see there's a legend. It tells you, yellow does not meet specifications, black does meet. I'm assuming this one is somewhere. Can you zoom to layer map from this page?
No. You just have to zoom in. You can't. It should, but the bounding box is incorrect, evidently.
And I don't know where that one was. So let's go back to the one where we know. So, even though this one is all yellow, which doesn't tell us a lot, you can imagine that there are some black cells in there. Nice thing is that you can go in, turn on the satellite layer. If we're in the map, if you're in the map and you make a new map, you can actually adjust the opacity so you can see through that layer and kind of verify that usually you can see the gaps that are underneath it. And if you, like we said, if you wanted to print this out, at this point in time, you would have to do a screen capture. So it's usually the print screen button on your keyboard, and then you could bring that out. So
Jason, you mentioned that there's certain layers in there now, and more will be added. Is that what you said?
yeah, layers will be added, but ideally, it'd be nice if end users are using this, if they upload a vector layer, that it'll be automatically added to that layer drop-down list, so you can select. So if you want to base it on features that you have, like say you're in a watershed group and the delineation is slightly different than anybody else, any of the layers that are on there, you could upload that layer through Geonode, use it in the selection of the area to delimit your analysis for, and then have a custom output for that area.
Yeah, it also would not be difficult to make it so you can just draw a polygon and then just do it for that area.
Yeah, so there's basically your screen grab from the previous page. Are we still hitting the wall?
It seems to have processed all the queued up requests.
One left. Somebody.
Oh, there's one. There's one right there.
There's a 79. So this is the modified one that we did. So we can turn that on, and hopefully one more time, Shepherdston. All right, so now we've got some positive hits, which is nice. And turn on that. So some of these may be because it's right on the riverbank. Sometimes you get roads. You can see that one. I don't know how well you can see it. Probably not too well, but there's a field right in there. So if we were in the maps, we could add the stream layer as well to this to see this. You could overlay whatever other layers are in Geonode to help you, guide you. But overall, that's the basic premise of the tool and how it would work. We can check real quick to see if the maps are up and running.
You mind if I ask who might have run the one that's ID 10? Field ID 10? You have that up on your screen?
Something, but it's not up here. It was
Okay.
one he just-
Because that one is running into problems. It appears to be something with the underlying data, but if I can identify it, we can look at it. It looks like maybe there's some blank values or something with that data, because it keeps on just throwing an error.
All right, so now that everybody's runs are done, so we can now add those layers. So these are all, and we should say the file is titled by the layer. So this was a HUC12, the identifier of the layer. Then you have your canopy, your solar gain value, your elevation, and your impervious surface if you chose those. So that's the nomenclature for the name. So this was the one that we wanted to add, so we can add that to the map. But down here you get add layers. Where are we?
Oh yeah, the default is in the middle of the Atlantic.
It's tough to plant out there. I can never get anything, bro. So we will zoom back in.
Yeah, when you start with no data layer as the initial layer, it throws you into the middle of the ocean.
Oh, actually, on this one you can zoom to there, right?
Yes, except, yeah, if it doesn't.
If the overlay is open.
Yeah.
Maybe.
Do you want to pick up that mic?
All right, so now if we go back to the left map, this is when you can, then you can adjust the layout.
Styles, yeah. And
Or
yeah,
the styles. But
yeah, but the opacity is probably more.
at this point, I just want to lower the, so maybe we'll zoom in before I make it go away. But, so then we go back to layers. We'll put on the imagery again. And we'll do a zoom. Zoom in a little more. That's exactly where we were before, huh? So we're picking up a road right there. Hopefully it's a dirt road. This one looks promising. Master is underneath it if you wanted to verify that these work. I'm not going to at this point, given that it's working hard. But that's basically the underlying premise of the tool and how it works. Questions?
How was the riparian area defined as far as you just look at an area I'm familiar with and it's a wide open ag field and it's not getting any hits?
So the riparian zone is 100 meters on either side of the stream.
But I was just picking up forested versus ag.
Those are from it's from the canopy cover there. So canopy cover gives each pixel a percentage of that pixel from 0 to 100 of how much canopy cover is in that pixel. That's from 2000. It's from 2001. That was the last time they updated it from the National Land Use Database. So it's using that, the canopy cover,
the riparians, which is just the amount of energy hitting it. And then if you use elevation, it's using the DEM, the digital elevation model. If you're using impervious surface, which is also from the same place as the canopy cover, it's a 0 to 100% of that pixel that's considered to be impervious. Mark?
So one thing I think would be useful is to take this tool and match it with what you believe your climate change model is. So, example, this could show up that these are, you know, so you pick something, so okay, here are the worst 25 sites, 25% off for climate, for solar gain in the spot, and here's the worst 25% for canopy cover. Well, let's say that area is in a high sensitivity, high exposure area that you don't think is going to persist down the future. So you could be planting trees that, no matter how many trees you plant, it's never going to become trout habitat because you picked an elevation too low, like in this case, or it's on the Shenandoah River or Potomac River where it's too wide.
Yeah.
If you pick the elevation, let's say, okay, we're at 1,800 feet, that's trout habitat in Virginia. So you pick 1,800 feet. And then you're also, now you're in the zone to protect brook trout. And then you can be in a zone, is it a low exposure, high exposure, looking at some of what your belief is on climate change, and you can adjust that elevation up and down and look at that. So.
And that's the nice part about being able to add it right to the map on this part where all the other layers will be, is that you can overlay all those layers and see what fits best for you. This is not, you know, just because it's black doesn't mean that's where you have to go. That just, out of those cells in that feature, that tells you those cells meet those criteria that you specify. But obviously you're going to have to do a little bit of legwork still and see if the, you know, where you would still get your best bang for your buck. And you could rerun this feature. So, you know, we used, 70, 90, and then whatever elevation. You could change that. You know, change it to 95% if you don't have that much sites, or lower it if you have more. So it's flexible that way. Any further questions?
So are there any other questions for Jason and or Matthew at this point? No?
How do you get this in the hand, not this audience, but the Department of Forestry folks, the DOF are the guys that were really interested in a lot of the southeastern states of using this, and then Farm Bill folks, prep and stuff. So that would be an audience, a marketing plan or outreach plan. The people are actually planting trees and stuff. So some thought to that, so they're more aware of this.
So you're asking how we get it to them?
Yeah, I mean, just having this without letting them know or teaching them or whatever. There's not too many. I mean, some of us in this room may plant a few trees, but most of the tree planting and the interest was from the Department of Forestry folks and Farm Bill folks that aren't really necessarily brook trout biologists. So an outreach or some thought process down the future to get this tool in people's right hands.
Yeah, I think that's part of the beauty of this is to have, and you talked about it this morning, of kind of that win-win situation of multiple benefits, multiple sector, multiple taxa. So it's the same thing that under the app LCC, we do have a formal rollout strategy. This is the first part of it, and as you know, we're videotaping it and adding that to the supporting training of the tool. So in terms of general outreach and through the Appalachian LCC, we have both districts, so region 8 and 9 of the Forest Service. We have, of course, the Northern Research Station and the Southern Research Station. So for the forestry component of that, we have that constituency represented. So trying to make sure that people know of your priorities and your needs and your opportunities to enhance your work is part of the intent of having this tool. So it's not just here is the tool for restoration, but here is the tool that, again, broadens the conservation output and the conservation within a regional context. So it is part of a formal rollout, Mark, and then again, part of the reason for having it in open source and not having to have membership is to have the widest possible distribution and access. And I do know there was some question about the kind of data information on who's using or utilizing our information, and so the portal does allow us to try to have more information on who's accessing data, downloading data, and supporting that. So it's hopefully a broader community than just the people that are involved in this joint venture or even in the Appalachian LCC.